Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Last time we started with um, vector fields, line integrals in vector fields, but we took a simple example where the particle was moving along a line segment. Today, we are going to look at a different case where the motion is not necessarily linear, okay? So here's the example. It's going to tell you your force. If we write the force uh, in vector form, it is yi minus, let's say, 2xj. Or you write it as y, comma, negative 2x if you are more familiar with this shape or form, I mean. Okay, but now our particle is moving along a circle. In fact, it starts from a point and it goes clockwise along a circle until it reaches the bottom here. So it's half a circle, semicircle. The center is at the origin, and it starts from this point, ends at that point. We can make, we can say it's a unit circle, but it really doesn't matter. I can pick any radius. Let's pick some value for r, and let's say r equals 2, for example. It really doesn't matter at all. And the motion is clockwise. I want to parameterize that. So I know I'm starting at a point 0, 2. I'm ending up at 0, negative 2. And somewhere in the middle here, when the angle is 0, I am at 2 and 0. Gonna use cosine for the x and sine for the y. And I can write r of t here as, notice, this angle here is pi over 2, and this angle here is negative pi over 2, and this angle is 0. I don't like that. The way I usually do it is that I start my motion from angle 0, meaning I'm subtracting pi over 2 from everything, uh, or adding, subtracting in this case. But I will be adding as I go here until I go from 0 to pi. And I adjust the sine and the cosine accordingly. I feel it's more natural to do it this way. But since I know the way you learn it, you always start with 0 as the x-axis, and then you go counterclockwise is positive and clockwise is negative. It doesn't really matter. So here I'm going to say, since um, this angle is pi over 2, I'm going to say 3 cos t in the x plus 3 sine t. Why did I say 3? It's 2. Sorry, guys. For some reason, I wanted to write 3 and then I wrote 2, change my mind. Okay. So you see that when the angle is pi over 2, cosine pi over 2 is 0. And when t is pi over 2, sine t pi over 2 is 1 times 2 is 2. When you go to the angle 0, you get cosine 0 is 1, so times 2 is 2, and sine 0 is 0. When you come here, cosine negative pi over 2 or 3 pi over 2 is 0, and sine 3 pi over 2 or negative pi over 2 is negative 1, so negative 1 times 2 is negative 2. Now, like we did before, we take r or dr dt. The derivative of cosine is negative sine, so I get negative 2 sine ti plus 2 cosine tj. And I don't forget to say that t goes from pi over 2 to negative pi over 2. So I'm going just to take the negative of the integral and make it from negative pi over 2 to pi over 2. Okay, so like we learned last time, I'm going to rewrite my force as a function of r of t. So it says y, well, the y is 2 sine t. Notice it's I. I don't try 2 sine t j. Minus 2 times x. But x is already 2, so I get minus 4 cos t j. Finally, I'm going to take the integral from pi over 2 to negative pi over 2 of f dot dr dt. When I take the dot product, I dot I is 1, so I get 2 times negative 2 is negative 4 sine square of t. And then I have negative 4 times 2 is negative 8 cosine square of t dt. I can take negative 4 as a common factor outside. In fact, I can make it 4 and switch the limits of integration. It really doesn't matter. Let's leave it. Here I get sine squared t plus 2 cosine squared t, but I'm going to write it as cosine squared t plus cosine squared t. And of course, you know why I did that. Because these two guys add up to 1. Okay? Notice that when we get the cosine square, we can always write that cosine square of t equals 1 plus cosine 2t over 2. So now my integral becomes negative 4 times the integral from pi over 2 to negative pi over 2 of 1 plus 1 half, meaning 3 halves, plus cosine of 2t over 2 dt. I evaluate the integral, so I get 3t over 2, right, 3 halves. And then this would be sine of 2t over 2 times 2, so over 4. And the integral goes from from pi over 2 to negative pi over 2. So I have negative 4 times. Remember, we take the first pair of parentheses while doing pi. So I get 3 times pi over 2 over 2. So 3 pi over 4 plus, if t is negative pi over 2, then 2t would be negative pi, and sine negative pi is 0. So plus 0 minus. I do the t is pi over 2. Oh, here, I'm sorry, here it was negative, right? 3, and this is negative pi over 2 over 2. But here it becomes positive, so I get 3 pi over 4. And the sine of pi over 2 times 2 is sine pi, which is also 0, so plus 0. So at the end of the day, I get negative 4 times negative 3 pi over 4 minus 3 pi over 4 equals negative 4 times negative 3 pi over 2, right? And negative 4, so that would give me 6 pi, right? Negative times negative is positive, and 4 over 2 is 2 times 3 pi is 6 pi. So that is the work done by that force. Notice that, as I said, I could have switched the negatives and everything would have been positive except this. So I would have 4 times 3 pi over 4 minus negative 3 pi over 4, and you get the same answer exactly. And it was nice that the signs canceled and I only had to integrate 3t over 2, really, right? Hope that was a short and easy example. I have a third example. I will go over it, but it's different than this one. So I'm going to leave it till my third and last session on that. And then we'll move and start discussing conservative vector fields and what they mean and how can they simplify things for me. Thanks very much for your time. If you have any comments or questions, please leave it in the comment section and I will try to get back to you as soon as I can. Thank you very much and hope to see you soon.